Hi, my name is Leonard Facchinetti. Let's write some code together, shall we? Yesterday was a difficult day for us. We were not making a lot of progress, but today we have a lot of new things on the menu. I worked on the library a bit off stream, and in case you just landed here, what we are doing is we are developing this library that allows you to create real time audio effects for Reaper. Great. The purpose of the library is to make the plugins better looking and easier to develop, hopefully. Right, okay, so let's get down to it. What is new? What have I done since yesterday? Well, I fleshed out some of the functions that were missing. I changed the demonstration effect. I added a lot of things. I'm going to show you the things that I did. Most of them, I kind of already covered the theory of them, so it's just a matter of having fleshed out the implementation, which is what I've done. I fleshed out the implementation. Then we are going to talk about the oscilloscope, which is not just an oscilloscope. It's going to be a component, user interface component, that is going to draw some signal over on the screen, drawing some signal on the screen. And I am making this distinction because it's not only for the audio signals. We may want to render something like a gain reduction signal on a compressor or something like that. And then in that case, the signal that we're plotting is not necessarily the audio signal. So we are going to start this component. It is going to be useful for when we revisit all the effects I have ever created to incorporate the library. There is a component, there is an effect that is an oscilloscope. It will be good to use this component when we revisit the oscilloscope, but we will also use this in many other places, like when we get to do a compressor, which will be in the near future, hopefully. And Arya is here. Hey, great to have you. I hope you enjoyed this stream. So let's go over what happened since yesterday, then we'll get into the oscilloscope. Oh, check your OBS. There is some wheel of loading going on. I don't see anything. What do you mean, Arya? Even on YouTube, the thing seems alright? Yeah, my preview doesn't show anything. I don't know. What was it that you saw? Huh. Right, so functions that were missing, unit conversions from milliseconds to samples. So if you call this with like 300 milliseconds, it's going to return to you the number of samples that correspond to that. And the ways that this works, oh, okay, false alarm. The way that this works is, I'm not really sure if I covered this before, but if you want to do something in terms of milliseconds, the sample rate is the number of samples per second. So you have to multiply this number of milliseconds by this, which is just 1/1000. Then if you think about it, for instance, if you want 1000 milliseconds, 1000 times this is going to cancel out. You just get the sample rate. So this number is going to be like 48,000. And that's how this formula works. Simple stuff. Then for the converse, what I did is just I resolved for, I guess I went like this. This is more or less what I did. And then I solved for milliseconds. So to do the converse, all I had to do was to actually do this. And then I was like, okay, but this can be simplified further. It's not really a simplification in the sense that it's not going to affect the number of operations. It's not going to make anything faster. But if you note that you are dividing by this, you can think of this as that. So this actually becomes this after you do a bit of simplification. And this multiplication and division doesn't matter in which order you're doing that. So there you have it. It's the same as what we have down here. So that's how this came along. Simple formula. And Bo is here. Hey, great to have you both here on this stream. Just to catch you up, Bo, what we are doing is we are covering the things that I did since yesterday. I was busy. I did a lot of things. All the issues we had yesterday have been solved. Right. Okay, so then I have the function that converts from Amplitude to dB. And there's something that I didn't do before in this implementation here. There is this, which is we did together yesterday. It's the formula for converting from Amplitude to dB. I have a video about this, a relatively old video. It exists in the channel. You can go check that out if you want to understand what this formula is about and where it comes from. But on my initial pass, I was missing the absolute value. I added that on the stream. But then something I was not doing is, if you have an amplitude of 0, that corresponds to minus infinity in dB. And of course, we don't have a value to represent minus infinity in JS effects. Not that I am aware of anyway. I mean, these are floating point numbers, and floating point numbers supposedly have a way to represent infinity. Now that I'm saying this out loud, I guess this is the advantage of writing code on the stream. I have to explain things out loud, and then I may notice something that could be better. It's like a code review of sorts. Let's see if the notion of infinity exists in JS effects. I don't think it does, but let's see. So I'm going to drop my demonstration effect on a track. And this is just so I can come in here and play with some JS effects code. So is there any notion of minus inf? No, that evaluates to the number 0. Infinity. No. And if I remember correctly, there are some languages, floating point infinity. There are some languages that use a different contraction of the word infinity to represent that idea. Positive and negative infinity. Yeah, some languages use inf, but we already tried that. I'm going to try it with a capital I just in case. No. And I remember some language using something like infinity, and they just like took away the vowels and probably did. No, I think it had a something like this existed in some language, but I forget what language that was. Maybe MATLAB or whatever. Okay, so it seems like infinity is not a concept in JS effects. Great. Arya asks, wouldn't -1 be minus infinity in floating point? Well, no. -1 is -1. Oh, sorry, wait. 0. Like, if something is minus infinity, wouldn't it be 0 floating point? Oh, are you saying that maybe infinity is represented with a series of zeros in binary? I don't know, maybe. There is here a section of this article that explains how infinity is represented. But it seems like it's not a concept in JS effects, so I'm not going to worry about it. But just for understanding it, let's go there. Positive and negative infinity are represented thus. So a sign of 0 for positive infinity and 1 for... Okay, so a floating point number is a a series of binary digits. They are divided in 3 sections. One is the sign, one is the other is the exponent, and you also have the mantissa. I think that's how it's called. And you have to put a sign, and then to represent infinity, you let the exponent be all ones, and the mantissa, the fraction, be all zeros. So that's the sequence of numbers you would see in memory for infinity and minus infinity. I don't think we have access to that in JSFX. What I guess I could do is just come up with this pattern of bits, and then I would say convert this pattern of bits into a number, and that could be a representation of minus infinity. I'm not going there. I am doing something that is a lot simpler, but also solves the problem. So I think it's a good solution. And I just noticed that I'm missing something here. I don't know how that was working, and I think it was, which is weird. But okay. So what did I do to represent infinity? Something simple. I just put a very low number there. So the minimum dB you can have is this fixed value of minus 9,999, and that is as good as silence, because I guess 120 dB is already pretty much silence anyway, so this is a very conservative measure. In any case, if my amplitude is 0, I should be returning minus infinity. That is not an option. I just return a very low number. Otherwise, I use the formula to compute the dB based on the amplitude. Straightforward. And then the converse, I don't have to worry about zeros or negative values or whatever, because this formula just works everywhere in all the points. Even for positive dB, if you're going over, that formula just works. So it's just the converse of this. Instead of taking the log base 10, you take 10 and you exponentiate to a certain power. Okay. Let me pop out the chat so it appears here on the screen when I'm reacting to something. It makes sense to have it on the screen, I suppose. Though you will also see that in the chat on YouTube, somewhere below me. In Max MSP, for example, you can multiply by 0 to get minus infinite output from a digital to analog converter. I don't think you multiply by 0, I think you divide by 0, right? Because multiplication by 0 is just 0, the result is 0. But in JSFX, if you divide by 0, you don't get any notion of infinity, you just get 0 back. Which I guess makes sense, because 0 is a relatively straightforward number to work with, while the concept of infinity blows up everywhere. If you try to multiply by infinity, you get infinity. If you try to divide by infinity, you get infinity. If you try to add to infinity, you get infinity, or even not a number, I don't know. Let's not get into that. Right, so then for mathematical functions, I have already implemented this before. I don't think anything changed about this section. Then for the data structures, enumerations didn't change. This changed. Memory allocation changed. And it was a very significant change. It was super important. Remember how yesterday we read on the documentation that if you have a serialized block, it is not REAPER is not necessarily going to zero out your memory before calling the init block every time. It does give you a zeroed out memory to begin with. When you just load the plugin for the first time, your memory is all zeros. But if you have a serialized block, it is not going to reset the memory every time. It is only going to reset the memory the first time. So before, I did not set the memory to anything when I was allocating memory, and that was carrying over. So when I would, for instance, define a data structure, that's a box that I keep adding 1 to, and then when the code runs again, I would redefine the data structure because I have to, but it would just, so all the variables have been reset, so I have to redefine the data structure, but the memory is not cleaned out. So my data structure definition just kept increasing and increasing. In any case, the solution is simple. When I'm allocating memory, I zero the memory before I return it to you. So this is just this single line changed. And I think we had it at some point, and then I removed it, and then it's back here. Whatever. We even had at some point a notion of you could customize the initial value, but I decided to ditch that. If you allocate some memory, it comes with zeros, the same behavior as when you start using JS effects and every other variable in JS effects. So that was a very significant bug, and it was a lot of time until I realized that this was the issue. So I didn't actually use any new debugging techniques that you didn't see me using on the stream. There is no secret sauce. It was just me doing what I was doing yesterday, scratching my head, suffering for hours and hours, and then good stuff came out. Yeah, but 0 goes out to digital audio conversion, no sound. Oh, if 0 goes out to a digital to audio conversion, no sound comes out, which corresponds to no input. Okay. So when you're doing this, there is some black box that is doing some conversion to dB. Is that what's going on? Oh, yeah, but we didn't do anything fancy in terms of this computation of dB yesterday. Moving on. So boxes didn't change. The structure definitions didn't change. I think that this is new. I don't remember if this was here yesterday. I added this notion of arrays, which it is a data structure that is super simple. In essence, it is just a block of memory, except that it keeps around its size. So I have a block of memory that I allocate, but I keep around what is the size of this array. And in many cases, when I am using blocks of memory, I don't need to know the size because the size is already determined by something else. I'll give you an example. I have here a bunch of delay lines, one per channel, and I already know how many delay lines I have. It's the number of channels. So I just allocate memory, raw memory. I don't need to use the array data structure. But in some cases, it is beneficial to have the size associated with the block of memory. And in those cases, I'm using arrays. I guess one instance will be right here in the circular buffer. Yes. So the way that the array works is it is a data structure that holds the size as well as the data. I didn't give this field the name signal. I could have given the name signal, but I decided to go with data because an array could hold other things that are not even signals. Below, we will have stuff that is called signal because I think that in a circular buffer, it makes more sense to call it a signal. In the array, not so much. And then to initialize an array, you just give me the size, and I store the size, and I allocate the chunk of memory for you. That's all there is to that. Then for circular buffers, I think that this changed as well. I am just storing the index into the circular buffer, the write head, so to speak, and the signal. The signal is an array. So the signal is going to know the size as well as the data, of course, but the signal is an array, as you can see on this line. So I don't need to store the size of the circular buffer. The array is going to store that for me. I just have to store what is the current index that I'm looking into when I'm writing or reading or whatever. And then the logic to push a sample into the circular buffer, even to get a sample given an offset. So to fetch out stuff from the circular buffer, the logic is the same. Maybe the only thing that changed was how I'm extracting the fields out of the data structure. Now I'm getting the signal, and then from the signal, which is an array, I'm getting the size and the data. Then for the simple moving averages, same story. It is a data structure that has a window. A window is a circular buffer. And I also store the current sum as I'm moving the window through the samples. And then the logic is what we had before. To push a sample into the moving average, I have to update the sum by taking out the value that is falling out of the window, and I add the sample that you are giving me. So I add that to the sum, I add that to the circular buffer. And the circular buffer is necessary because when the thing wraps around and that sample is going to become irrelevant, it falls out of the window. What happens is I need to have that in the circular buffer to be able to subtract that, to get rid of that sample. And again, just to reiterate more on this logic of the moving average, for more of how this works, why this works, you can watch my previous videos about RMS. There is a series of 4 videos about that, way back in the channel. Relatively old video. Then to get the moving average, I just get a hold of the sum and the window size and divide one by the other. So I keep a running sum, but I only divide by the window size when you are requesting something, when you're requesting the average. And there is an alternative implementation in which I divide by the window size before I add to the sum. So I could split this window size division over here, and that would amount to the same, because A plus B divided by C is equal to A divided by C plus B divided by C. So it doesn't matter if I divide here or if I divide there. I decided to divide here because when I haven't implemented this yet, but I think I will want to be able to change the window size without having to allocate everything again. I would just be able to tweak the window size. So to do that, I will need to go over some samples and remove them from the sum. And to do that, I think it's better to just have the sample right away instead of having it like this, because the window size, if the window size changes, C is going to change. So if I keep this information around, it's easy for me to just go and maybe B needs to fall out of the window. I just subtract B and I'm all right. But if I am changing the window size, C, so I will have stored these guys, then I would have to do some extra work to compensate for that. I have to multiply everything by C and then divide by the new window size. Yeah, okay, that's a tangential point. We will get to a point where we will want to implement something to let the user change the window sizes on the simple moving average. This is this item right there. And I did the way I did the things the way I did the things because I'm preparing for that. But it should be said that if you're getting the value from the moving average more often than you're pushing into the moving average, then this implementation is not optimal. Though, to be honest, I don't think that's the usual case. Usually you push into the moving average and you get from the moving average. Usually that's how it works. Sometimes you would even push to the moving average more often, like on the sample block, you would be pushing into the moving average, but you only read from the moving average in the GFX block because maybe you're collecting some samples to display, like in an oscilloscope. We may do that today, not with a moving average, but with a circular buffer. And in that case, it really makes more sense to just divide when you really need to, not all of the time. Okay, moving on. An RMS is just a special case of a moving average in which I am doing something special to the sample as it comes in. So I guess the RMS is kind of an oddball because it's not a data structure in and of itself. An RMS is just a moving average, but it is special in the sense that when you push and when you get, I am changing the behavior. So effectively, what I'm doing is before I push into the moving average, I am squaring their sample. And when I'm getting from the moving average, I'm square rooting what comes out to undo the squaring. And I guess if you think of this library as object-oriented code, then you can think of this as inheritance. This is inheriting from the simple moving average. That's one way of conceptualizing this. Aria asks, is it possible to slow down the display of an oscilloscope? So like not freezing, not real time, but just something that still evolves over time, but is just slower than actual audio. Well, of course, but the physics of the situation is that you are trying to slow things down. So either you are going to miss some of the signal, maybe the audio. So you're going to miss some of the audio and you're going to skip some of the audio, or you are going to be lagging behind, right? There is no other solution. You are saying that you want to go slower than real time. So either you're going to have to skip some portions, or you're going to be missing what is coming and what is new. So I suppose that you are asking that because sometimes the signal is so fast that it is hard to understand what's going on. It could be advantageous to be able to slow things down, but then when you speed things up again, you're going to skip over some parts that you missed. Is that the issue that you're trying to solve? And Bo asks, there is a good point on doing a double RMS where you square the input twice and then square root the sum twice as well. I'm typing like I'm drunk. Sorry. You don't have to be sorry for being drunk. It's fine. I'm joking. I know you're not drunk. So I have never heard of this RRMSS that you're proposing, where you square and then you take the square root twice. Why is that advantageous? Oh, it makes a difference in the sound of a compressor. Cool. I didn't know that. And it is just a fundamental thing that you would have to do. You would have to square this twice. There is nothing you can do about. There's nothing you can do about it after you have put everything into the moving average. But I guess what you're proposing pretty much amounts to these lines. If you want to implement this thing that you are proposing, I can do it right now, though I don't think I'm going to keep it. But all you got to do is just this. And you have implemented this variation that you're proposing. Now, I'm not going to keep it right now. Maybe if we need that in the future, we'll do it. But there you go. And then for the biquad filters, what I did is I quadruple checked my implementation of the formulas. I don't think I found any errors. Other than that, I think that this is the same. And then the initialization is still the same. All right. Oh, Bo is not drunk, but he's really, really tired. It is not that different, actually, in terms of cognition. Right. So I did all of this, but how did I check that everything was working right? Well, I went into the demonstration thing, which is using the library. You can see that it's importing the library. And I did a bunch of work here as well. In fact, there is 260 lines of code of test for 460 lines of code of implementation. So it's almost half. So there is a lot of work in here. First of all, I brought back the notion of pages to test the different parts of the library. It's something that we had before. I just brought it back. Then I have some sliders here that we are going to play with in a moment. Then I'm importing the library. I'm doing the initialization of the library. I have an enumeration that is not using this enumeration implementation because I need these numbers to match the numbers that will come out of the page slider. Then I have a maximum delay length. So my slider for delay length has this maximum. We'll get to why we have a delay thing going on here. But then what I have is a better unit testing framework kind of thing going on here. Before we just had little dots and Fs on the screen to indicate tests and failures. My intent is that I want to be able to change the implementation of the code or just verify that the code is working. And I want to just have a couple computer programs that are going to execute these functions, test if they're doing something that makes sense. That's what a unit test is. But before we just had dots and Fs to say if the thing was passing or not, I decided to improve on that. So now we have proper error messages. And then if the test fails, then we know what failed. So this is new. I developed this yesterday. It's a unit testing framework, very rudimentary for JS effects. The way it works is I just run all my tests as a Boolean, conditional, and then I add to a string and I put new lines. So if multiple tests are failing, then I will have one per line. And I just add to this errors string. And then at the end, in the GFX block, I just write this string to the screen. I didn't yet bring back my design system, so I don't have the colors. Right now, the color is just white on pure black. Whatever. But this allows me to verify. And oh, another thing that is important, I'm running these tests in the init block because I only want to run this once. Before I was doing that in the GFX block, which is kind of silly because it was rerunning the whole test suite 30 times a second. Right now, I'm doing this on the init block. I'm running these tests only once, and if they fail, I add to this string that is going to be written on the screen. And the way that this works on the plugin is I can load the plugin into the track, and I can go to the tests page, which I guess is the first one, so I don't have to do anything. And if I don't see anything, all the tests are passing. If I see something, then it means that that test is failing. For instance, if I change this 0 to a 1, then I do a full compile reset, it shows the name of the section that is failing. So I know that I need to go there and I need to do something like this and peek, and then I'll see that this part is okay. And then I will do this and peek, and I'll see, oh, this is the test that is failing. What is wrong about it? Oh, it should be a 0. Okay, now it's passing. Now, the weird thing is, after the errors string has been changed, not even a full compile reset is going to fix that, which I guess is a weird quirk of JS effects. You have to remove the effect and bring it back. And now you can see that the test is passing because we don't have any message on the screen. So I don't know why strings behave that way. They just do. Not even a full compile reset is going to erase the memory that holds strings. Too bad. But it's all right, I think. You just have to remember to delete and re-add the effect on the screen to the effects chain. And you can already peek. So I found that the ergonomics of these are not perfect, but they are not too bad either. Right, so I have tests for all the functions we looked at. I don't think I have any function that has not been tested. And they are just simple tests like the number of samples for 1,000 milliseconds or a second is the sample rate, half of that is half of the sample rate, 0 is 0, and so on. Amplitude 2 dB, very simple stuff. Half amplitude is minus 6 dB. And if you go negative, minus 1 or minus 1 in terms of amplitude is the maximum that is representable. So it is 0 dB. And then you can even go over if you're clipping. And then the number 2 in terms of amplitude is the converse of half. So it is positive 6. That's how logarithms work. Then for the converse, I just pretty much took the values from here, but it does not make sense for me to talk about dBs that are negative infinity. I don't have a way to represent that, so that's why there are fewer tests here. No, but hang in there. I didn't even test for anything that is going to be negative infinity, so maybe I am missing a test. Well, but there is one thing. Positive amplitude and negative amplitude maps to the same dB value. So it is silly for me to have too many tests for negative and positive. No, what am I saying? Both of these inputs are mapping to the same number. So then when I'm doing the tests on the converse, it would be just literally this, because my dB to amplitude is never going to return negative amplitudes. It's always going to return positive amplitudes. So that's why there are fewer tests here. And in one of these, there is a test for minus infinity. Here it is. There we go. And then for these guys, I just put these functions into Wolfram Alpha, took the result, pasted back here. Some simple snapshot testing is what this is called. In case you don't know, Wolfram Alpha is like a Google, but it has a calculator that knows how to do mathematics. Then for the enumeration, simple stuff, we did this test already before. I'm just testing that the enumeration items are going to be different. For the memory, I just store some stuff in there and check that the stuff is there. Kind of trivial. For the boxes, same stuff. For the struct, kind of the same deal. I just put data in there and get it back out. For the array, I check the size and I get the data back out. For the circular buffer, I push stuff into there, I get it back out. I even check the index, though it is kind of an implementation detail, but I even have a test for that. Then for the moving average, same stuff. I am adding a value in the beginning because I have a moving average of 3, so I am adding a value to the beginning so that it will be overwritten. And then I even check the sum, which is again an implementation detail, but I check it anyway. And then the average between 30, 50, and 25 is 35. Note how this has fallen out of the window. So I am testing that the window is comprising of only those numbers. And then for RMS, same story, but in this case, I actually put the formula here for checking the sum and the square root. All right, so then we have some other tests that are actually, you have to run audio through the tests. They're not automated tests, but you can play around with them, which is kind of cool. So I have a delay line, which is testing the circular buffer. I have RMS, and I have the filters. And for RMS and for the circular buffer, I have automated tests as well. But for the filters, I don't have automated tests. I can just test using audio. Then I'm going to skip the slider section. I'm going to leave it for last. Then on the sample block, what I'm doing is I check in which page I am. If I am in the circular buffer page, then I am going to do the delay thing. And this is the main reason why I wanted to do the library with real objects, right? So we are coming back to the issue of having multiple channels. And in fact, my delay is multi-channel, my filter is multi-channel, my RMS computation is not multi-channel, it's mono for now. But on the to-do list, multi-channel RMS, it will exist. It's relatively straightforward even. But I was getting tired and I had worked on a lot. I mean, I spent the last 40 minutes covering what I did yesterday instead of starting the oscilloscope. But let's finish this because there is a lot of good stuff to talk about. So I just loop over the channels. I take the sample from the channel. I get that delay line. So I have now an array of delay lines. See, I allocate. It's not really an array because I don't need to store the number of channels as I explained. That is already something that I have. I already know how many delay lines I will have. And if you change the number of channels on the track, I suppose that this is going to reset and restart from scratch. So it is fine. The init block is going to run again, and then I will have a new chunk of memory with new delay lines. So I have one delay line per number of channel and per channel, not per number of channel, but I have one delay line per channel. So I don't need to store this as my array data structure. So for now, my array data structure is only being used in the circular buffer, not in this guy right here. And then I allocate a new circular buffer per channel. And then what I do here for the delay is I push a new sample into the delay line. I get a hold of the old sample given a certain delay length, and then I take the average of the two. So in effect, this is a simple delay with a single tap. I'm going to show you the rest, and then we are going to hear all of these guys in action. Then for RMS, I'm just pushing the left sample into the RMS computer, And then I'm using a slider and I'm showing this in DB. So I get a hold of the RMS for that guy and I show that in DB, and I have a slider to show the RMS. You're going to see what that looks like in a moment. And if I am doing a filter, then I just go over the channels and I filter using my previously configured filter. All right, let's hear what this sounds like. Let's just test the whole thing. Let me remove the effect and add it again because that's a good measure. And then let's start with the filter, why not? So I have all these pages here. Let's go to the filter. Yes, this is a low pass. And you can see that I'm using the trick that is showing and hiding the sliders. And this is a relatively new thing in Reaper. I think it was 6.30 or 6.35 that brought this new feature. We're going to go over the code that does this because it is interesting. We had a stream of like 2 hours talking about this slider show function. And I think I found a better way of using it that is very straightforward. Really like what came out of that. So you can see that the sliders for the biquad filter only show up when I am in that section, when I am in that page. And then I have all of these options and they all worked as advertised. I can even move things around and I have different width types. And the coolest thing I think is that the width type of slope only makes sense on shelves. And then the width type slider adapts to that and only shows that option when I am on a shelf. And this is such a basic concept in UIs. And yet so many people get it wrong. And you may be wondering what's going on? Why is there no bell here? And that's because the gain is 0, okay? Or not a bell, a shelf. Yeah, so it's a common problem in many effects. I guess I can show an example in Recomp. If you have auto release, then this slider doesn't do anything, I think. Why is it there? It shouldn't be there. If a slider doesn't do anything, it could be grayed out or it could be removed from the interface entirely. But it shouldn't be showing up. I think that is such a basic design thing that I'm not sure that this is the case right here, but I think it is the case in many other effects. In my case, if a slider is not doing anything, it should be hidden. How do I do this, however? It's easy to use the slider show to show and hide sliders, but how do you hide an option from a slider? That's impossible. You cannot do that. So how did I do it? Well, I have 2 sliders with kind of the same material except for the slope. And then I hide one or the other. So they have the same label and some of the same options. So if you're not paying attention, you're not even going to notice. But the truth is that when I move from shelf to peaking, this is a different slider. And I even wrote a little bit of code just to do the smart thing of when you are in the S mode, if you switch to a peaking mode, it is going to switch to a mode that exists, bandwidth or Q. And then I calibrated all of these kind of, I eyeballed and I copied from other plugins. I think I copied the Q range from ReQ, and I copied, and when I say ReQ, I mean this. You can see that the range is from 0.1 to 40. So I have 0.1 to 40 here as well. And bandwidth, I copied from ReQ from 0.01 to 4. And when I say ReQ, now I mean this. They sound the same. They're not the same. 0.01 or 4. There you go. Now let's briefly look into the code that made this magic of the sliders showing up and hiding. Oh no, before I do that, let's actually go to the other kinds of tests. So for RMS, you can see that it's computing the RMS of the clicks that are coming through, but let's make something more interesting. How about I disable this for now? Now there is no audio coming through, but I can always enable this for recording and move it to my microphone. And then this is actually computing the RMS of my voice as I speak. as my microphone is picking it up right now. Great, huh? And I used a slider as a kind of output, which is a cheap trick that some JS effects use. The way that it works is just you have a slider that it needs to have a default value. And the default value I'm using as sort of a marker here for 0 dB. Then a range, I decided to go from minus 90 to 12 on steps of 0.1, but it doesn't really matter the step, for instance. You can see that this step here is not being respected at all. And then what I do, by the way, cool trick, huh? You can use the namespacing dot thing even on slider names. Then I just assign to that slider and it updates itself. It's as simple as that. Then for the circular buffer with a delay, this is working on my microphone, remember? So there is a delay of 1 second. So when I speak something, you can see that it comes back again. See? It's repeating. I'm not going to actually put this so that you hear that, but just trust me, it is doing a delay and it's working fine. And there is actually a cool trick when I was testing the delay. So if I have a long delay, and let's not have any audio coming through except for the Burton EQ curve analyzer. So if I have 0 samples of delay, I have a flat EQ curve because I am not doing anything to the signal. But if I have 1 signal of delay, not going to hit enter yet, do you know what is going to come out of this? What is the frequency response of a single sample of delay? Do you remember this? We wrote this together. I'll give you the answer. Is there anything else that I can do? Yes. I'm going to give you the answer. I'm going to press enter. But before, I will let you think about it and write it up on the chat. I'm not going to spoil it for you. So, what is the frequency response of a single delay of sample? A single sample of delay, not a single delay of sample. A single sample of delay. What is the frequency response of that? Let's go to the code that is doing the slider tricks, and then we'll talk about what is the frequency response of a single sample delay. Yeah. Before I even get into the code, Bo is right. A low-pass filter, that is right. It is averaging 2 samples, the current sample with the previous sample, so that average is smoothing out the fast transitions in the audio, so the fast or the high frequency changes. So that's a low-pass filter. But what happens when I increase this to 2 samples, 3 samples? So I'm not looking at all 3 previous samples and averaging them. No, I have the current sample and I have 3 samples ago and I average. Or I have the sample and I have 5 samples ago and I average. Just these 2 samples, the current and n numbers and n samples ago. What is that? What does that look like? So yes, we did together on the stream this low pass filter, and you're saying notch. Not quite. See what I did there? Not quite. It gets interesting. Let's do 2 samples. 3 samples. It looks like a notch so far. But there is another one. It's a bunch of notches. So when we are doing the low pass filter using that cool trick that we did together on one of our first streams, that is fine. But that low pass filter is actually just the tip of the iceberg. It's peeking through, but what is actually there is it's a comb filter. And the more I increase the number of samples, let's go to like 30, you can see the comb coming through the spectrum. It's already 100 samples and the comb is coming through. It is coming through. And then when I get to like 250, this first bump is going away. It is going to disappear. disappearing. Let's go to 400, 500. And at this point, at about this point, this is already below 20 hertz. Am I right? What is the frequency here? I don't know. I cannot tell. But oh no, I guess 20 hertz is here. Yeah, okay, now it's gone. It's below 20 hertz at this point. And then I can keep going. But as I keep going, it is just more and more of this peaks and valleys coming through and sweeping through the sound. And this is how, what is the name of the effect that works based on this with comp filters? There are three kind of modulation kind of thingies. Phasers, but this is not a phaser. A flanger, and I forget what the third one is. But I think there is a Blue Cat implementation of this. A chorus, a flanger, and a phaser. Yeah, so if I remember correctly, a flanger is just this that we implemented, but you keep like moving the slider left and right using an LFO. That's a flanger. You're just delaying samples and you are changing how many samples ago you're adding to the current sample. So if you keep doing this, I think that this is a flanger. I don't think it's a phaser. A phaser is a different thing. A phaser, if I remember correctly, a phaser is a series of all-pass filters, right? So that's another thing we can look at. On the filters, let's go to all-pass, and let's show the phase response of our thingy. So you can see that, of course, the bandwidth is not going to affect, or the Q for that matter, it's not going to affect the frequency response in green. It is going to affect the phase. And I think, if I remember correctly, a phaser is a bunch of all-pass filters. It's not going to change that, but it is going to be doing this. So it's going to keep changing the phase. And if you have a series of these, I don't know how many, or even if you need that many, but if you just keep doing this and you modulate this, I think that this is a phaser. And Bo answered my question. Flanger, phaser, and chorus are the three ones. Yeah, flanger is delay-based and phaser are filter-based. Yes, if I remember correctly, I was reading about this the other day. This is a phaser. This is, oh, now the phase response is crazy. This is a flanger, and choruses are delay-based, but longer in delay, so the effect is different. Yeah, so if you're like in this range, then it is going to be flanger. And if you're at this range, it's going to be a chorus. But the effect is, the principle behind it is the same. You just hold on to some samples, a very short delay, before you can actually hear the delay. Because when I do it, for instance here, it's a 1 second delay. You can hear this as delay. You hear a clap, you hear another clap coming back. But if you're here, you don't hear the claps, just hear the difference in the frequency response, like that. Cool drawings, crazy stuff. I don't think I'm going to get to the oscilloscope at all today. Let's see the code for the sliders. What I'm doing is I am using this slider show function, and I learned that you can pass the name of the slider that you gave here. That's a simpler way of doing this, instead of doing what we did on the stream way back, where we were like computing some powers of 2, or we did some bit shifting, things like that. No, just give the slider name. It works. Great. And then I want to show the slider under this condition. So this is the pattern that I like using. It's not the same. I looked for instances of slider show in all the JS effects I have installed, and the only instance is in the loudness meter, this new JS effects by Cocos. And they are not using it the same way I'm using it. And I think that my way of using it is actually nice because it is very declarative. I'm saying that I want to show this slider under this condition. If this is true, it's going to show the slider. If this is false, it's going to hide the slider. Very declarative. What is the condition under which I want to show the slider? Perfect. Bo says, yeah, it's comp filtering the comp filtering. Yeah, right. I find that crazy. That is fascinating to me. Now, the RMS slider is only going to show when I am in the RMS page and so forth. But then for the filter stuff, I have to do a little bit more work because I have to hide and show the sliders in a more sophisticated way. And I have to map from the values that are going to come out of the slider into my enumerations. So let me show you, for instance, this slider. There are these options, and this variable is going to be 0 when I am using the low pass filter. So I have to map 0 to that. Another way I could have done this is I could have a section of memory, just a little array kind of thing. And I'm going to write in syntax that does not exist in JSFX, but it exists in languages like JavaScript or whatever. But I could have some sort of array like this. And then I could index into this array with this. And it maybe would be more declarative than doing this bit where I compare to the numbers, but there you go. I decided to just write it like this. And other than that, I don't think there are any cool tricks here. Yeah, it's just a matter of finding all the specific cases where I want to show and hide the different sliders, and it's kind of manual and boring work. The more interesting part, of course, is this. I loop over the channels to configure all the filters. All the filters on all the channels are going to be the same configuration. Yes, Bo, it is extremely fascinating, at least to me. Right, so that's all I did yesterday. Let's start on something for today, right? Let's do something today besides just reviewing what we did yesterday. So I want to create a component that will draw a signal on the screen. And I'm not even sure how that is going to play out, but I think I'm going to call this the oscilloscope. No, first of all, I cannot seem to write oscilloscope. There you go. But I'm not sure I want to call it the oscilloscope because the meaning of oscilloscope is tied to some audio signal or some signal. And we may want to show something else on the screen. So this is more like a line graph. And the oscilloscope is an instance of a line graph. Maybe I'll have graphs, and a line graph is an instance of this. Maybe we'll have multiple. One thing that I definitely need is the signal. I think I'm going to represent the signal with circular buffers. Then I need some information about where I'm going to draw this. So I'll have X and Y and width and height. These are the typical parameters you would find in the GFX functions. Then I will also need stuff like, I'm going to comment this out for now because I'm going to revisit this. I'm not going to implement it on our first pass, but we need the colors. We may not even need the colors. We'll see. And I may not want, I think I may not want to plot the whole signal. As Aria was bringing up before, you may want to like slow down the signal, or you may want to pause on the signal or whatever. So I think I'm going to just like have an explicit value. I could extract from the signal. A signal is a circular buffer. A circular buffer contains an array, and an array knows its own size. So I could extract the size from there and always print the whole thing. You know what? I'm going to start with that. I'm going to start by printing the whole thing. So to do, zoom horizontally and vertically. That's what I mean when I'm printing part of the signal. I'm zooming horizontally. And I could not print to the whole width and height. So that would be zooming in vertically. I guess I'm going to concentrate all my to-dos at the top. Another thing that I know I will want is just a line or an area. So am I going to just draw the line, or am I going to like highlight the whole area below the curve or something? Let's start with the simple stuff. From the signal, I will need to extract its size. Let's see an example of me doing that somewhere else. This is an example of me doing that. Of course, in this case, it's called a window, so is there any other instance in which the signal is a circular buffer? No, this name is already loaded. Yeah, signal is something that exists in the circular buffer, so let's not conflate these two ideas. I'll not call this the signal. I will call this the data, right? If this is a line graph, there is some data going on. And I think I missed something when I copy and pasted stuff. There you go. So this is called the window on the moving average. But the data is already a circular buffer, so I can just do that based on the data. And I will have some data size as a local variable. So yeah, the data is going to be a circular buffer. I get the data out of the data. Man, that is no good. And then I take the size of that array. Hanging there, I don't think that this is right. Yeah, this data field doesn't exist anywhere, so this is a problem with me copying and pasting wrong. Let's go to the window size stuff again and try to get it right this time. Right, so I have my data, which is a circular buffer. I take the signal, which is an array, and I take its size. Now I have it. And I guess I'm going to use some GFX thing. So let me find the docs for that. So actually draw on this screen. And Bo is saying, I can totally geek out on ways to do averaging in different ways and how they sound. Yes, we should talk about this when we get to, I guess, other kinds of filters beyond just the basic biquad filter. And pardon my word jambling, my brain is fried. I feel you. I'm kind of the same. Don't worry about it. So I can draw a line. Let's start with lines. And I will have a local variable that is my index. Or maybe even my... No, it's going to be my index. And my index is going to start at 0. I'll call this, no, I think I'm going to start at -1. Then I will loop for the data size number of times my index plus 1. So this is a straightforward loop of me looping over every position in the circular buffer. Then I want to draw a line. The line is going to go from x plus I need to have the width of a single data point. So I guess I will have a variable called data point width. My data point width is the width of the whole component divided by the data size. So my x position is the x that you want me to draw on plus the data point width times the current index. As for the y position, it actually depends on the previous y. So I guess what I'm going to do is I'm going to use a different GFX function. I am going to use the line2 function. Anti-aliasing 1. Why am I using the data with the line2 function instead of the line function? Because the line2 function remembers and updates the GFX x and the GFX y variables. So I don't have to do this bookkeeping myself. Then where do I want to go to? I want to go to y minus because I want positive values to be above. So, I guess I need to have the height midpoint. I'm assuming that the line graph is going to be like an oscilloscope. The 0 is going to be in the middle, positive values above, negative values below. We may have to configure, we may need to add configuration for all of this. The height midpoint is the y plus the height divided by 2. Then my y is going to be the height midpoint minus, midpoint is a terrible name. I will revisit this. Minus, and I will make the assumption that the numbers are between 0 and -1 and 1. So I guess I am kind of doing an oscilloscope here. But I will generalize this by having other options, maybe. I'll see. So what do I want to get? I want to get something from the circular buffer. Let's use the circular buffer get function. And I need to pass my circular buffer, which in this case is my data. And I need to pass the offset, which in this case is minus index. It's going to start at -1 and then at 1. So it's going to start at 0 and it's going to go up to data size -1. That is right. What is incorrect about this, it seems, is that I am going on the circular buffer in reverse. I'm going from right to left. So I think I want to do that here as well. I want to go from right to left. So I am going to subtract I don't need to compute this explicitly, so I can just subtract data point width. So I guess my GFX to X to begin with is the X where you want me to draw plus the width. And we start at the height midpoint. Well, actually, we need to start at position 0. Otherwise, there will be a line from the midpoint up to our first point, which in most cases I don't think would be noticeable, but you never know. So I'm actually going to start from 0, and I'm going to loop -1 times. Then I'm going to the left, and I am doing the height midpoint minus... Oh, and I need to multiply this by... I guess I need another variable for half or height half. I definitely need better names for these things. This is the height half. Height half. And then I multiply by that. Okay, yeah, I think that this makes sense. Let's try it out. I'm going to commit what I have in case I have to change stuff around, but let's have another page. Or maybe maybe it makes sense to have this as a page somewhere else. Maybe I'll just add this to the circular buffer test. I have ambitions for that, so I'll start there. I already have a delay line, so I could just show the delay line. That makes things very convenient. So if I am on the page of circular buffers, I think that's the name of the page. Yes, page circular buffer. So if I'm on the page circular buffer, I am going to set the thing to white. And I'm going to call my lovely little function. What is my data? That is my delay line. My x is going to be like 10 and 10, and let's do 200 by 100. And then here we can edit, full compile or reset, close, go to a circular buffer, and I see a graph. And the graph is not bad because this is the impulse train given by the curve analyzer. But let's hear this on my voice. And there you go. We have kind of an oscilloscope going on. So I fulfilled my promise. Of course, there are still more things that we need to do. This is not perfect. There is this line hanging in there, and I have no idea why. Let's see if we can tell just by a brief glance. I don't know. I don't know why that line is there. But that line is there. So there's still, of course, more stuff for us to do, but whatever. Let's wrap this up. I did what I promised I would. We did kind of an oscilloscope thing. So thank you all for being here. Thanks for supporting me by just being active on the chat and by supporting me on PayPal, Patreon, all that good stuff. And have a great weekend. And I see you on Monday. On Monday, what we are going to do. What are we going to do? I don't know. We could be doing some of the things that we find here. What do you want to do on Monday? Let me know. I think one thing that we could do is, since we have kind of an oscilloscope thing going on, we could have some sort of frequency spectrum analyzer thing going on. So yeah, maybe let's do a frequency analyzer. That could be fun. And when I say a frequency analyzer, I mean something like this. Oh, this instance is set as a signal generator? No, not good. There you go. I mean, something like this. We could do something like this. We would work with FFTs and everything. That could be fun. Yeah. Maybe that's what we're gonna do on Monday. We'll see. All right. Have fun. Have a great weekend. I see you on Monday. Bye.